Welcome to this essential guide for technicians and advanced DIYers. Today, we're diving into the critical topic of sensor bypassing, focusing specifically on 2-wire and 3-wire sensors. Sensors are the vital data providers in any system, but when they fail, understanding how to temporarily bypass them can be a lifesaver in an emergency. This is a temporary fix, not a permanent solution. First, let's understand the difference. 2-wire sensors are typically passive devices, like thermistors or reed switches, that change their resistance or simply open/close a circuit. They're often connected in series with a load or to a control module that provides a reference voltage and measures the change in resistance or continuity. 3-wire sensors, on the other hand, are active devices. They require power, VCC, ground, GND, and provide a signal output, SG. These sensors are common in applications requiring more complex data, such as proximity sensors, Hall effect sensors, or pressure transducers, providing a voltage or current signal. Before attempting any bypass, always, and I mean always, disconnect power to the system. Safety is paramount to prevent electrical shock or damage to components. For a 2-wire sensor that acts as a simple switch, if it's normally open and stuck open, you can bypass it by creating a direct connection or a short circuit across its terminals using a jumper wire. This simulates the switch being closed. If it's normally closed and stuck closed, you would disconnect it entirely, creating an open circuit to simulate it being open. Always refer to your equipment's wiring diagram to confirm the sensor's normal operating state and its function within the circuit. Now, let's move to 3-wire sensors. These are more complex due to their active nature. Identify the power, ground, and signal wires using your service manual. If the sensor provides a high signal, e.g. 5V, when active and it's stuck low or open, you can bypass it by connecting the system's signal input directly to the appropriate voltage source, usually 5V or 12V, using a jumper wire. Conversely, if the sensor provides a low signal, e.g. 0V or ground, when active and it's stuck high or open, connect the system's signal input directly to ground using a jumper wire. For sensors that provide a variable voltage signal, bypassing becomes more challenging. You might need to use a fixed voltage regulator or a resistor network to simulate a normal operating voltage. This requires a precise understanding of the sensor's expected output range and the system's input requirements. Consult your service manual for specific values. After implementing any bypass, double-check all your connections. Incorrect wiring can lead to severe damage to your control module or other components. Restore power cautiously and monitor the system closely. The bypass sensor's protective or operational feedback is now absent, so manual vigilance is critical. Remember, bypassing is a temporary emergency measure. It removes a critical safety or operational component from the system. Replace the faulty sensor with a new, functional unit as soon as possible to restore full system integrity, safety, and optimal performance. Proper diagnosis and safe bypassing are invaluable skills for emergency situations, but they are never a substitute for a permanent, correct repair. Thank you for joining us. Stay safe and keep your systems running smoothly.